So let's begin with the sequence. So here from the previous session 4, we had proved 2 theorems. So here we are going to start with the third theorem, that is every convergent sequence is bounded. To start with, let xn be the convergent sequence. So if it's a convergent sequence, what do we know? That limit xn as n tends to infinity is L. It is converging to L. This is for all epsilon greater than 0. There exists m belonging to n such that modulus of xn minus L is less than epsilon. This is for all n greater than m. Right, this is from our definition of the convergent sequence and the definition of the limits. We are able to write like this. Now, since it is modulus of x minus L is less than epsilon, we can write this as it is lying between minus epsilon less than xn minus L less than epsilon. This is for all n greater than m. Now we are going to add plus L throughout. So what are we getting? L minus epsilon is less than xn. L plus L minus L gets cancelled, and here it is L plus epsilon. This is for all n greater than m. So now here we can see that the terms of the sequence here after the mth terms are bounded. They are bounded between which limits? L minus epsilon and L plus epsilon. So now what we have to show is, now to show that for all n belonging to n, k is lying, xn is lying between small k and capital K. That is for some real numbers k and k. Let's take this small k and define this capital K. This small k be the minimum of x1, x2, etc. x of m minus 1, L minus epsilon, L plus epsilon. Similarly, capital K be the maximum of x1, x2, etc. x of m minus 1, L minus epsilon, L plus epsilon. So we have defined the small k, that is the minimum of all the values, and capital K is the maximum of all these values. So now what is this? Small k is less than or equal to xi, because it is the least, so it is the minimum. So where I is ranging from 1, 2, 3, etc. to m minus 1. So we know that small k is less than or equal to L minus epsilon and L plus epsilon also. From this we are able to tell that they both are less than that. Similarly, if I take xi, which is less than or equal to capital K, for all I is equal to 1, 2, 3, etc. m minus 1, then we know that L minus epsilon, L plus epsilon will also be less than or equal to capital K, right? So now let us write down the range from where it is k and small k can be written. So small k is the least, so will be less than or equal to L minus epsilon. So that is less than xn is less than L plus epsilon, which is less than or equal to my capital K. This is for all n belonging to capital N. So from this we are able to write that small k is less than or equal to xn is less than or equal to capital K for all n belonging to n. So what we found? We found that xn, the sequence xn, which was convergent, is now bounded between the limits the small k and capital K, and hence we have proved the theorem 3.